Hi, this is Aaron Lewis from Franklin Maths. This is the second video on the normal distribution. The last video was a bit short because I only had a 15-minute time limit, but hopefully this will be longer and clear up any misconceptions from the first video or as you've been working through the questions. So, I want to just cover some misconceptions first. So here is my normal distribution. And you can see that I've got a mean of 10 and a standard deviation of 2. So these are a couple of questions that I didn't cover in the first video, but I'll hope to cover off now. So what about if the probability was equal to a number? Probability of less than, I know that I did cover in the previous video, that there's something I just want to touch on. And then I didn't cover a modulus function in terms of probability, but a greater than. Again, this is in the modulus part of the course, but I thought I'll recover it quickly. So the first question then is x tilde normal distribution. We've got a mean of 10 and a standard deviation of 2. So it's worth always, when we start one of these, just to write things down. So mu, the mean is equal to 10. Just put that pen a second. We know that sigma squared is equal to 4. Remember, then that's the variance. And therefore, sigma is equal to 2. Even though this question doesn't ask for those, I've wrote them down anyway. It's just good practice. So there's the distribution. And if you want to pause the video at this time and without using your notes, can you remember how this needs to be labelled? Yeah, feel free to pause it now, and then I'll write down any relevant points on this. Okay, so this number here is going to be 10 take away 2, so that's going to be 8. This number here is going to be 12, 14, 16, 6, and 4. And remember, you got a couple of inflection points. Inflection point here, and inflection point here. So the question we've got here is what's the probability of x being equal to 9? Well, if we sort of define the probability as being an area, so here's my line, there's 9, roughly. Well, what's the area of this line? Well, it doesn't have one, does it? So in this case, it would be 0. And in terms of continuous, it's very hard to get an exact value. If you think about measuring something, how accurate does your ruler need to be? So if you've got a probability of x equal to a number with a normal distribution, it's 0. Remember, with binomial though, you would get an answer. For a discrete distribution, you would get an answer. Okay, so hopefully that clears that one up, and this would be a 1 marker in your exam, and it's worth just remembering that. It's worth putting on a flashcard and looking at maybe once a week or once every 2 weeks, just writing that going, oh yeah, it's 0, with a little picture underneath it and maybe an explanation that the area is 0. Part 2, probability that x is less than 9. I did mention this before, but it's that section there. I've had a couple of questions emailed to me saying, Aaron, what's this one equal to? So in this case here, this is the same as the probability of x is less than or equal to 9. Those two are equivalent, so it doesn't matter in your calculator what you write. You just need to have an upper, so let the upper be 9 and the lower can be something which is at least 3 standard deviations away from the mean, at least less than 4 there. Okay, so you could choose 0, 3, minus a million if you really want to go for it, but it needs to be at least 3 standard deviations away from the mean in your calculator. So those two are the same. It doesn't matter whether there's the equals part on the inequality or not. Okay, and the one I didn't get time to cover is this one here. Now, what this sort of means is which numbers are more than 3 away from 12. So I'll cover that first. I'll just delete that. Okay, so what you guys are expected to do in your exam is, first of all, let's have probability of x less than 12 is greater than 3. So in this here, notice, sorry, I don't know why I put 13 there. Just look like an actual 3. Now, because it's greater than, if you think about this in terms of distance, so 12 is your center, and I want more than 3. So if I draw a quick number line, ish. So there is my number line. I would have 12 in the center, and I want to know which numbers are 3 away. So all we're going to do is break this up into two separate inequalities. X minus 12 is greater than 3, or x minus 12 is less than minus 3. And you just need to add 12 onto each one. So x is greater than 15, or x is less than 9. And that's what we were saying a minute ago. If we had 12 in the middle, which numbers are sort of 3 away? So it's that one there. Don't colour it in because it's not got the equals built-in inequality. And so if you can't remember out of this, go back through your notes and find it. This is a useful little skill, and the exam board do expect you to be able to do this. Okay, there you go. And then the question is how do you work this out on your calculator? So there's 9. And 15 is there. So I want that red section there. I'll just put in the other numbers. So if I just colour this one here in a second. When I did this last year with my other students, we had two choices. Some students decided to work out this probability separately on a calculator, which can be done. Absolutely fine with that, and writing down all the decimal places. Same with this little bit here, which is absolutely fine. Another thing to do, if you wanted to, you could find, I'll just change colour a second. Go for blue. What you could do is find the area of this blue section here on your calculator, and then subtract that from 1. It doesn't actually matter. The complete area underneath the graph is equal to 1, just like all probabilities add up to 1. So you could either work out two separate probabilities and add them together, or you could work out this probability here between 15 and 9 and subtract that from 1. It doesn't actually matter. So hopefully that's covered that, and then if you made a mistake in the first couple of questions, don't worry about it. Redo those now. Hopefully that's helped you out. Okay, and moving forward. Now, all these normal distribution curves have the sort of same shape. So this is ours here. Now this one on the right here is known as the standard normal distribution. If I teach you, I'll keep saying normal distribution because it's just bizarre to me to go standard normal distribution, but I completely understand why it's written like that. So if you have a look here, you've got 10 and you've got 0. This mu could be anything, and all you can see is it's just a translation. So we could translate this curve and move it over towards 0. And if it's got a slightly different shape, we could either stretch it or squash, but again, that's still a stretch, into this curve. And if you want to convert that, there is an actual formula for it, okay, in terms of working out the standard deviations. We'll cover that in a later video, but I believe your calculators do it as well. So I'll have a look at that now. But we'll do it by hand first, and then we'll have a look at the calculator. I'm just going to change my pen ink back to red. Okay, so the question is, how many standard deviations away is x equals 12.5 away from the mean? So we know from earlier this number here is 12, this number here is 14, this number here is 16. Okay, and so we go, yeah, and I can sort of see how far it's how many standard deviations away it is. It's definitely 1, isn't it? 1 and a bit. Again, we could work that out, but it's always nice in math to have a general formula. So the formula that you guys need to know is if we say z is sort of the value, a z-score tells you how many standard deviations away a number is. So z is then equal to x minus mu divided by sigma. If we look carefully at this formula, if we minus mu, that's going to translate it, and dividing through by sigma there is going to stretch it or squash it, but it's still a stretch. Okay, so all I'm going to do is sub in the numbers. So if I want to work out z, which basically tells you how many standard deviations away something is, we're going to take x, which in this case is 12.5. We're then going to minus mu, so we're going to take away the mean. We're going to divide through by the standard deviation, sigma, which was 2. So in this case here, that's 2.5 divided by 2, which, so just run out of space there, which is 1.25. So we're saying that the value of 12.5 is 1.25 standard deviations away from the mean. Now this will mean a bit more when we do hypothesis testing, but that's quite important to know how far we are away, because the further away we are from the mean, the less chance of the event happening. Okay, so this is a conversion of how to get this curve into this one by undoing transformations. Okay, now your calculator, I can just pull it up a second. You'll notice you've got Z scores here. So I'll have a look now at that. So if I go to, I just press exit there, go to dist, norm. I'm going to press NPD this time, it doesn't really matter. I'm going to go for variable. I'm going to say my x value was 12.5. My sigma was 2. Mu was 10. Just go down to draw. And it's given me those, but it shouldn't really give me a probability value there. Okay, that's just the nature of these calculators. But if I go backwards a second, go to dist, go to norm, go to NCD. Let's just have the upper as 1,000,000 or something like that. Doesn't really matter. Sorry, my lower. So let my lower be 12.5. Let my upper be something ridiculous. Fill in the rest. And if you have a look here, it's given me the Z value. So because I put my lower in as 12.5, and we know, by using the maths and using the formula, we know it's going to be 1.25. The upper value didn't matter. I was just getting it to work out a probability for me. If I go to draw here, looking at it, will give me the Z value on these calculators for that 12.5. And obviously the upper one is, nearly 5,000 standard deviations away from the mean, which I'd expected. I just chose a really, really large number. So that's quite nice to do. That relates to question 2. So it's up to you. You can pause the video now and get on with question 2 from exercise 21A, or you can carry on watching the video. And then I've got question 2 and 3 together, and then you can sort of finish off the rest of the worksheet. Okay, so the other style of question, which you'll see here, is find the value of x, which is 1.2 standard deviations away from the mean. All we're going to do is use the same formula we just did a minute ago and change it ever so slightly. So notice this time we were not given an x value, we're actually given the 1.2 standard deviations away from the mean. Now, what you'd be expected to do in your exam is to straight away is call that a z score. Let me scrub that z out there because that's not technically right. I've just copied and pasted. When we're using z, it's using this standard normal distribution here, which does have its own special set of parameters. So z tilde n 0, 1. This is the standard normal distribution. This one is quite nice to work with, and all normal distributions that we have can be converted into that one by either moving the mean or translating the mean across and then dividing through by the standard deviation. It is quite nice too, but we will be doing more of this in later videos. Okay, so if we've got 1.2 standard deviations away from the mean, that tells us then that z is equal to 1.2. Okay, remember these here, this is 1 standard deviation away from the mean, 2 standard deviations below the mean, 3 standard deviations way below the mean, and vice versa for those ones there. And so if you remember from the previous slide, z is equal to x, it could be capital X, doesn't really matter at this moment in time, minus mu divided by the standard deviation. So I'm going to fill in what I know. 1.2 is z, that's equal to, now we don't know x, we know that mu was 10, and we know the standard deviation was the square root of that, 2. So we're going to double this up and solve. So 2.4 is equal to x minus 10, apologies for my handwriting there. So x is equal to 12.4, and again I could just check that on my calculator easily enough. It doesn't really matter. If you've got time in the exam, feel free to check it, but with these new A levels, time is always quite pushed. The stat stuff is pretty nice to get on with. It's more to remember, but less problem solving. So this bit here, the actual maths involved here is fairly easy to get on with. It's just remembering this formula and knowing what you're subbing into. Just remember that when you're working with a z or a capital Z, you're working on this distribution here. So it's all about how many standard deviations away from the mean you are. Okay, so what I'd like you to do is to complete question 2 from exercise 21A. The reason I'm spending quite a lot of time on the basics is that when we're introduced to a topic, it's really, really important that we get all the fundamentals in place before we start. Before we start problem solving, we need to make sure we're completely happy with what we're working with, because all the questions after this are all involved with more questions, and certainly once we know the probability of something, we can then ask more things. You have the chance of it happening 3 times, so we'd be cubing. So that's stuff to watch out for, but just question 2 for now, and then I'll put a separate video up for sort of question 3, and then after that you can get on with the rest of the sheet.